Alright, welcome back to another video. So today we're going to go over recursion and recursive functions. So pretty much what recursion is defining the problem in terms of itself, or pretty much when we're making functions, it's using the function inside of itself to get a result. So let's say we have the Fibonacci sequence of this order. Now, if you're unfamiliar with the Fibonacci sequence, let's make a recursive function here where we take a parameter n. Now, the Fibonacci sequence is if we have a number such as 1 and we take the number before it and we add it to this number, we get 2. 2 plus 1, 3, 3 plus the 2 is 5, 3 plus 5, 8, and so on, and it continues. So, if we have, let's say, where n is our index, and we have up to, in this list here, we have an index up to 9. Let's say our index of 2 and below, it will just be the result of itself, of like the number you input. Because if we go to input 3, it's just going to be pretty much just 2, and that's not correct if you just say 3 is 2. Okay, so if we say if n is less than 2, so for these two values, it's 0 and 1, we're just going to return our value n, or our index that we just put in. So in any other case, so this being our base case, for any other case, we're going to return or create our value n, which will be the Fibonacci at n minus 1 plus n minus 2. And then we're going to return this to our code. So let's say if we have 9 numbers, which is 10 minus 1, we'll do n equals Fibonacci to all these numbers. We'll print what it is. Okay, so if we print these values, we should get everything in this list here. Now, if we do 21 plus 34, our next value should have been 55, right? Yes, and it continues and continues. So what we're doing is pretty much going from the top number and reducing it down and adding these two together. So we're pretty much going back to the base case as many times as possible, and we're adding ones and zeros and ones and zeros until we get our number, and it's equal to the n. Okay, so another function is, let's say we have a recursive function for making or finding the factorial. So let's say if another base case here, if n is less than 0, well, we can't use negative numbers when it comes to factorials. So we'll make another case here, an exception being if n is 1 or less, then we'll return 1, because 1 factorial is 1, and 0 factorial is 1 as well. So otherwise, we will have to make n equal to n times factorial minus 1. Okay. So what we're doing in this case is we're multiplying, let's say, number 6 by the number 6 minus 1, by the number 5 minus 1, and that minus 1 all the way back to the base case. So when we perform this, let's say we want to do 3. Now, in factorial, if we have 3, that is 3 times 2 times 1 is equal to, let's say, 6. So let's let our function do the math for us. Now, we're going to print this n value, and we should get 6. Now, if we do factorial 4, it is 4 times 6, and we should get 24. And 5, 120. So now we have a function that can use itself, the function itself, inside of itself to create our math problems for us and solve other unique equations and problems. So yeah, this is how we can use recursion in Python, and thank you for watching, and hopefully you learned something.